Hello friends, welcome to Rajesh Data Engineering. In this video, I am going to talk about one of the performance optimization technique, which is deletion vector in delta table development. What is deletion vector? Deletion vector is one of the performance optimization technique provided by Databricks. To be more precise, it is one of the storage optimization technique. When I explain, you will understand how it is optimizing our storage. In order to understand deletion vector, it's very important to understand the internal working mechanism of delta tables. I have already covered that concepts in another video. I'm going to give the URL in the description box. In case you haven't watched that video, I highly recommend to watch that video before coming to deletion vector. Coming to delta table, how it is supporting data manipulation operation. Whenever we are creating delta table, it is going to create delta layer which is going to keep .json log files, which is going to maintain the metadata of the delta table, which means how many Parquet files we are having, how many columns we are having, what is the latest version. It is going to maintain those information in the JSON log files. And coming to actual data, it will be stored in Parquet file. And it is supporting time travel, which means the previous version of the Parquet files will be maintained internally. It will not be cleaned up until unless we execute vacuum command. So I have already covered these concepts in my Delta Lake series videos. Right, coming to deletion vector. First we can understand what is the performance or storage issue with the regular delta table development. Let's say I am having a product table which is having 20 records, and those 20 records are written into one single Parquet file. Now we are having JSON log file which is pointing to this Parquet file as the latest version. Now imagine I have to delete one record out of these no these records from my table. I have to remove one record. Then I am just issuing delete from table where ID equal to one product ID I am giving. So what happens is, out of a huge amount of data, we are going to delete small portion of the data. So what happens? Delta engine will understand this query. Based on that, it will go to the original Parquet file which is having 20 records. It will load that into the memory, and from the memory, it will remove those deleted records. Then there are 19 more records which will be written into another Parquet file. Why? Because Parquet file is immutable in nature, which means directly we cannot edit any Parquet file. So Delta engine will read the entire data into memory, and it will remove deleted records. Then it will write remaining result into one of the Parquet file. So within the storage, we are going to keep two versions of the file. One is the previous Parquet file which is having 20 records, and another Parquet file which is having 19 records. And also our JSON log file will be updated. JSON log file will be pointing to the latest Parquet file which is having 19 records. So any user is going to query, then Delta engine will go to the log file. Then it will understand what is the Parquet file we have to use. Based on that, it is going to return the result back to the user. So this is how delta table is working internally. Now you can understand, just to remove one single record, how much compute is needed, because the engine has to scan the entire Parquet file, and it will be loaded into memory. Then it will remove unwanted file. Then it will write it once again as a new Parquet file. So this is very complex process, and it is going to be time consuming, and also it's having performance bottleneck. Just to avoid just to handle these kind of scenarios, Databricks has come up with one very efficient feature which is called deletion vector. So in the deletion vector, whenever we have to remove small portion of the data out of huge amount of data, instead of rewriting the data, what we can do, it is going to create another deletion vector file which is going to be in binary format, which is going to just maintain the index number of the original Parquet file. This is the index number. In this index number, there is a record. We are not interested in those records because those are deleted. It is going to create one simple deletion vector file which is going to maintain only the index information, which means this particular record is deleted. It is going to maintain that information, and it is not going to create any more Parquet file. So later, user is querying select star from that table, then the delta engine will go to the JSON log file, and also it will consider the information from this deletion vector. Based on that, it will remove those records from the final output to the user. This is how it is working. I hope you understood. So basically, This is a very simple idea, but you can understand how effective it is in terms of performance and also storage. And while reading, it might add little overhead because earlier it will simply refer only the JSON log file. But coming to deletion vector, it will refer number of deletion vector files also. It might add little overhead to the performance while reading, but compared to the gain that we are getting from this overall process, that overhead is negligible, right? So coming back to deletion vector definition, deletion vector basically it is preventing rewriting of delta files when we are applying some changes to small portion of the data. And using this technique, deletion vector files will mark the deleted or changed records within the Parquet file. So it is a kind of soft delete. It's not going to remove the record actually, but it is going to mark these are the records got deleted or modified. So basically, deletion vector is nothing but optimized bitmap file which contains a set of rows of particular Parquet file that are no longer valid in a particular version of the delta table because it got deleted or updated. Right. I hope you understood what is deletion vector, how important it is, and in case you have decided to use deletion vector in your development, then in case you have to create a deletion vector enabled delta table for write operations, then we have to use the Databricks runtime version minimum of 14.3 LTS. And in case you have to read from some other solution, some other project, they have already created delta table and they have enabled deletion vector, and you have to read those tables for your operation. Then for read operations, you need Databricks runtime version of 12.2 LTS onwards. Right. And coming to this deletion vector operations, currently it is supporting only three manipulations, data manipulations like delete, update, and merge. Insert is not considered for deletion vector. Why? Because whenever we are inserting, new Parquet files will be created. So we are not going to touch the old data because we are not deleting or we are not modifying. So as a result, deletion vector is not needed for insert operation. So deletion vector that is applicable only for delete, update, and merge. And coming to syntax, in case you are going to create delta table with the deletion vector enabled, then we have to use the syntax delta dot enable deletion vectors equal to true. So we have to use regular syntax like create table, then we have to specify table name, then we have to give options if any, then within the table properties we have to enable deletion vectors. And let's say you have already created some delta table earlier, but deletion vector was not enabled while creating the table. Now you want to enable. How we can do? So for that we can go with alter table statement. So this is also usual ANSI SQL standard. Alter table, we have to give table name, then set table properties, we have to enable deletion vector. This is how we can enable deletion vector for our existing or new tables, right? And do you think these deletion vector files will remain forever or those are needed forever? Definitely not, because whenever we are going to create so many deletion vector files, it's going to impact performance on the reading side. So at certain duration, we have to apply those soft deletes permanently into the table. So what are the scenarios when these soft deletes are getting applied permanently into the table? So whenever we are executing the commands like optimize, auto compaction, which is auto optimize, or reorganizing table. These are the commands basically used to combine multiple Parquet files, rearranging the data layout within the delta table. So I have already explained the concepts of optimize, auto optimize concepts in other videos. In case you haven't watched, you can watch. With the help of these operations, the underlying Parquet files will be rewritten. So while anyway we have to rewrite those files. So during those scenarios, this deletion vector can be understood by the Delta engine and it can apply those changes. It could be delete, update, or merge. Those operations can be applied directly onto the file. Then next time onwards, Delta engine directly refer only those Parquet files. Then it does not need to refer deletion vector files anymore. But still, the older version of the Parquet file along with the deletion vector files will remain there. In case we have to remove, then we have to apply vacuum command. I have already covered that concept as well in another video. You can watch that as well. Right. I hope you understood what is deletion vector and what is the importance of that, how it is improving storage plus performance. Now let's get started with the demo. I have logged into my Databricks environment. I have created a notebook for this exercise. My cluster is up and running. And in the first cell, I am creating sample data frame, which is a product, which is going to have 20 records. This data frame is having the columns like product ID, product name, category, price, and stock quantity. Let me execute so that we can see the output of this data frame. And here we can see this is the output. And I'm going to write this data frame into delta format in a specific location, which is temp delta product catalog. Right. Then in the next step, I'm going to create delta table. So for that, I'm using the syntax create table. I'm giving a table name which is product underscore catalog for that particular location. Now let me create table, and I want to see the output within the table. So let me execute so we can see the output. So this is the sample table that we are going to use. This is one of the delta table that we are going to use for our demo. I'm going to create two different tables. So this table is going to, I'm going to show how it is going to perform without deletion vector. Right. So here we can see there is a table which is having 20 records. Right. Now we have created this delta table. I want to show you what are the files got created for this particular delta table. So let me execute file system command, which is list, and here we can see for this particular table we are having delta log folder, which is going to maintain .json and Parquet files, .parquet files, which is checkpoint files, and the actual data files, which is also Parquet in nature. Here we can see this is our delta log folder, and this is our actual Parquet file. Here it has created only one file. Right. Let me show you in the Databricks file system also. Let me go to this location temp delta and product catalog. Product catalog. Here we can see only one Parquet file got created, and it has also created delta log, which within there we can see .json log files. Right. Now going back to my code, I'm going to show the history comment for this particular product catalog table. Let me execute. So it is going to show the list of operations got executed for this table so far. So here we are having only one version because just we have created the table. So the operation is right. This is the only operation we can see. Right. Now what I'm going to do is I'm going to delete one of the record out of these 20 records. Let me execute. I'm deleting product ID equal to P004. So one record will be deleted. So now let us see how it is working internally. Now after this deletion, I'm going to see how many files got created internally for this location. So let me execute once again the file system command, and here we can see the delta log folder, and also there are two Parquet files. And here you can carefully see the size. This is the original Parquet file, which is having the size of 2177 kilobytes, and this is having 20 records. And on top of that, just for the simple delete operation, it has created one more Parquet file, which is having the size of 2161 kilobytes, which means just we have removed only one record. Even for to remove that one record, this delta engine has read this complete file, and it has removed that one record. The remaining result set it has written into this new Parquet file. This is what's happening internally when we are applying any data manipulation operation on delta table. Right. Now let us try to understand the history comment for this table once again. So it is going to give two operations. One is write, then after that we have performed delete. And if you come to this operation matrix, here carefully you can see here it is telling number of removed files. Number of removed files, which means it has removed one file from the JSON log entry because the previous version file that is not needed. Which file got removed? The big file which is having 20 records, that got removed. And in this delete operation, here you can see 19 records got copied. So in order to delete one record unnecessarily, it has copied 19 records. And uh, we can see other information. These are very important information. Number of deletion vectors removed 0. Why? Because we haven't enabled deletion vector for this table. That is the reason it is 0, right? And it is going to give other information like number of files added, this is 1, and what is the size of that file. So it is going to give this information. Now we can clearly understand this particular operation has read the previous Parquet file and it has rewritten once again. And here deletion vector is not enabled. I hope you understood how it is working internally and how it is going to occupy more storage. Now let me go back to this file system and we can see the same once again. Product catalog. Here we can see there is one more Parquet file got created. And if you go to this delta log, it would have created another JSON log file as well, which will be pointing to only the new Parquet file that we have created. Here we can see. Right. Now let me go back to our notebook. Now I am going to create another table with deletion vector enabled. Now we are going to see the difference. In this example, I am going to create another table called product, where I am giving table properties deletion vectors enabled as a true. Then I am going to copy all the data from our previous table product catalog. So let me execute. So basically it is creating table, and next let me query the table. So it is going to display those 20 records. Sorry, here we deleted one record. So here we are having 19 records, right? So this is our new table. Now we can understand how it is going to work internally. So first I want to understand this table is enabled for deletion vector or not. In order to check that, we can use describe detail command. So for my product table, I'm going to execute describe detail, and here we are having one property called deletion vector enabled or not, that we can see. Coming to properties, here we can see deletion enable, this enable deletion vector, that is enabled or not, true. And if you are going to check for the same command for previous table, it will be false, right? Now we have confirmed for our table deletion vector is enabled. Now I want to see the list of files that has created for this initial creation of the table. So I'm using file system command. Here we can see it is having delta log folder, and also it is having only single Parquet file which is having 19 records. Let me go back to this location, user hive warehouse product, and we can see how many files got created. My product table, and if I'm going to check, it is going to give delta log table and one Parquet file. And inside this delta log table, it's going to show the JSON log files. Right. Now let me go back to our demo notebook. I'm going to delete one record. This time I'm going to remove P003 product. So let me execute. Once this is executed, I'm going to see the number of files got created within file system. So as per Delta Lake internal working mechanism, whenever we are deleting some portion of the data, it is going to recreate the Parquet file. But we have enabled deletion vector. Now we are going to see what's going to happen. Here we can see delta log folder, and also we can see only one Parquet file now, which means the previous version, I mean another new version of the Parquet file has not been created, because it was having 19 records, the original Parquet file with a size of 2161. The same Parquet file we can see, even though we have deleted one, ideally it should have only 18 records now. So it should have created another Parquet file with less size, but that has not happened. Instead of that, here you can see it has added one binary file which is .bin, which is nothing but deletion vector file. So inside this deletion vector file, it is going to tell the particular index from this Parquet file that is not needed anymore. That record is deleted. It is going to keep that information. So someone is querying this table, select star from product, then Delta Engine will go to this delta log table and it will understand the log information. Along with that, it will also read this deletion vector and it will understand what are the records marked as a soft delete. It will consider everything into consideration, then finally it will return the output. Even though this file is having 19 records, but the Delta Engine will remove one record while giving the output back to the user. So this is how internally deletion vector is working. which means here we have avoided creation of another Parquet file. This is very simple file for this demo, but practically we might have a few GBs of Parquet file also, and we might have millions of records. So we can see very big performance and storage difference for those real-time use cases. Right, now I'm going to execute describe command, history command after executing the delete statement. So here we can see we have created the table first, then after that we have deleted, and I'm going to look at operation metrics. Here we can see this time earlier it was showing number of removed files 1 because the previous version file got removed from the JSON log, but here it has not been removed. Still, because the previous version of the Parquet file is considered. On top of that, deletion vector will be considered. So here another property you can see number of deletion vectors added 1. So the combination of this log file along with this deletion vector information, it is going to identify right version of the data for data analytics purpose. Right, this is how deletion vectors works internally. Right, now as I mentioned, whenever we are performing optimize or auto optimize or reorganization commands, then it is going to combine the internal files. So what is going to happen is, let's say I'm going to apply optimize command for this table. So currently we are having these things. So the delta engine will understand what file got deleted, then it will apply to the previous Parquet file and it will rewrite the file. Then the JSON log information will be updated, which will point to only the latest Parquet file. So it will ignore these two files. But at the same time, as per Delta Lake principle, it will not remove any old data from this folder. It will remain there. In case we have to remove, then we have to use vacuum. So now I am going to show this optimize command and also vacuum command. Coming to optimize, let me execute optimize first for this product table. Now optimize is completed. As a result, it has removed one previous version of the file and it has created added new file, one version. Right. Now let us see how many files are existing under this folder for product table. Now here we can see delta log. Within that we are having a deletion vector and we are having one Parquet file which is having 19 records, which is the previous version. Now it's outdated, invalidated, and the new version of the Parquet file which where no soft delete got applied based on this deletion vector information. Now you can look at the size of this file also, new file. Right. Now the JSON log file will be pointing to only this new Parquet file. Let me go back to the file system and show you. I'm going to refresh this product table once again. Here we can see it has added one more Parquet file. But the previous Parquet file and also deletion vector, they are not needed anymore until unless we are interested in time travel. Right. Just for example, I'm going to show you how to remove these unwanted files from the storage location. Let me go back to my notebook. I'm going to clean up the old files. So I'm going to execute vacuum. For vacuum command, by default, the retained duration would be 7 days, 168 hours. But in case I have to reduce anything less than 168, then I have to specifically configure certain Spark parameter. So that is what I'm doing in the first step. It's completed. Now I'm going to apply the vacuum command in this cell. So it started cleaning up the old files which are not needed, even though it got created just 0 hours before. Right. Vacuum command got completed now. Let me execute the file system commands once again so we can see what are the files remaining under the folder. So now here we can see only the delta log table which is having list of JSON files which is going to point the right latest Parquet file, and we are having only one Parquet file which is going to have 18 records. Now you understood how we have to clean up, or whenever we are performing optimize command, how those soft deletes are getting applied. Now let me show in the file system as well. Here if I am going to refresh my product table, here we can see only one Parquet file because the previous deletion vector and the previous version of the Parquet both got removed because they are not needed anymore for our data analytics purpose, because that is not reflecting the latest version. So within the delta log, we can see multiple version of the JSON files. Right. This is how deletion vector is working, and you can understand the importance of deletion vector. I hope you understood. If you like the content of this video, please like and comment in the channel. and also don't forget to subscribe. If you want to get the latest information about Databricks development, please click on the bell button. Thank you.